Hi everybody, welcome back. Over the last several months, I've had a number of people ask me for help when configuring autofocus within Nina. I can understand the confusion, especially if you don't know where to start. My goal with this video is to give you a repeatable process that will get you configured quickly and correctly. As a bonus, I'm going to introduce you to the R² threshold that is now definable in Nina 1.11. This is something you want to know about, and yet another reason to move to 1.11. Every electronic focuser, when paired with a telescope, is going to behave a little bit differently. You may get lucky if you try to use someone else's configuration, but in most cases you'll find it just doesn't work. There's definitely some consistent configuration processes you can follow and some best practices too. For this video, I'm going to start with my Pegasus Astro Focus Cube 2 that's paired with my Celestron 8-inch SCT. After that, we'll quickly go through my 61 EDPH2 telescope that's paired with a ZWO EAF focuser. And finally, I'll show you what it looks like to configure autofocus of a Canon lens using the Astromechanics ASCOM-based EF lens focuser. As a first step before diving into configuration, get your telescope close to focus and identify a star on the screen, potentially even zoom into that star. Nothing too big, but nothing too small. From that point of focus, we'll begin to move out of focus until the star on the screen we're watching grows by about 20 to 50%. That's going to be our initial step size. From there, you can follow the rest of my process. Let's go ahead and dive right into my configuration. Okay, so there's a lot of questions on how to properly configure autofocus within Nina. And I'm going to try to take you through what I found to be the best practices, and I've gathered this information from a number of places, including the documentation, which you can read. So I'm in 1.11, the latest nightly, as of right now, 95, I just upgraded. And let's go look at our autofocus. And right now I've kind of set most of it back. So right now I've got a autofocus step size of 50. I'm doing 10-second exposures. You can certainly shorten that if you want. Star HFR, parabolic. I recommend that you move to hyperbolic and try that first. Number of attempts, I believe defaults to 1. You can set it to 2 if you want to redo attempts if you have a failure. I don't change brightest stars. I'm not going to change outer crop or inner crop. I'm going to leave my binning at 1. We'll talk about R² threshold here in a minute. Some other things, we're going to turn off guiding during the autofocus. That's fine. I'm going to have a 2-second settle time. You may or may not need that depending on your focuser and your scope. I'm going to do 1 exposure per point. If you get a lot of errors, there's some red bars. If your red bars are really big, you may find that setting more exposures per point can help with that. Just know that your autofocus runs are going to take a little bit longer, so I'm going to leave that at 1. Set overshoot as the backlash compensation method. You need to do this, change it from absolute to overshoot prior to connecting your focuser. And the first thing I'm going to do, we'll just do a 5-second luminance image. So what I want to do is try to find a star, and I want to get near focus. If you're not currently focused, the first thing you need to do is get near focus. This actually looks pretty good. This is good enough right now for me to be near focus, so I'm okay. So the next thing I want to do is try to determine my step size. And I had previously set a step size of 50, and it defaults to something. I can't remember what it is. It doesn't really matter. So I'm at 134/320 on this particular focuser. This is a Pegasus Astro Focus Cube 2. I'm going to go ahead and set it to 134/370 and move. Now this is going to move me 50. Which is what I'm currently defined at. And what I want to do is then, once I'm moved and settled and I'm there, I want to take another frame and I'm going to compare it. So I'm going to keep my eyes on this and I want to see if this star grows. And if it does grow, did it grow by somewhere between maybe 20 and 50%? And I don't think it did. So I'm going to try something bigger. I've already moved 50. Let's try to add another 100 to that. So that'll be a total of 150. So I'm going to go up another 100. I'm going to do move. So I've moved a total of 150 in that direction. Let's go ahead and do this again. And I'm trying to get to a point where it moves noticeably. And again, it's not really moving for me. This particular focuser has very fine step size definitions. So I need to move quite a bit. So I've already moved 150. I'm gonna try to move maybe another 400 and see what happens. That'll be 550. So let me go ahead, as I need to move after I set it, let it move the focuser. I moved, and now I can take my image, keeping an eye on that star. Okay, that definitely changed the star size. So I'm at about 550, so let's try to use that as my initial step size. So what I did is, again, I'm trying to move manually to determine when I'm having noticeable star bloat and growing by maybe 20 to 50%. It's going to be difficult for you to get these numbers exact, but if you see some noticeable growth and it is not ridiculous growth, you're going to be okay as a starting point. So that's going to be my starting point. So I'm going to go ahead and we'll leave it just like this for now. I'm not going to change the focuser. I'm going to go into options and go to autofocus again. And what I'm going to do is, I said that was 550. So again, I don't have any backlash compensation, anything. So I'm going to say 550, and I'm going to lower this right now with my luminance down to a shorter exposure time just for this video. So we've made that change. I'm going to go back to imaging, and I'm going to go to autofocus. Now, if you don't have autofocus here enabled, you can click on it up here to get the screen to pop up. But my autofocus tab is here, and I'm going to go ahead and say start autofocus. And it's going to run through an autofocus cycle. Now, there's a couple things you want to see here. The first thing is that you're looking for steep sides and hopefully a nice U shape, or potentially what could be a soft V, right, with very steep sides and a rounded bottom. We want to have between 1 and maybe 2 points at the bottom. And the other thing we'd like to have is that the highest HFR that we have, right here we're almost at 12, the lowest HFR that we come up with, we want the highest one to be a multiple, maybe 3 or 4 times our lowest number. So what I typically see people do is they end up where they're not getting a good curve, and unfortunately when you look at their HFRs don't move much, right? Maybe they're staying between 5 and 6. You want your lowest HFR on your graph, when multiplied 3 or 4 times, to equal the highest point. If you don't have that, you need to dramatically increase your step size. So we're starting to get what hopefully would be a curve, but you can see on the right-hand side, we've got a flat section, and then we're starting to now go down a steep curve. And we're up around 12 and down around almost 4. So we've got our multiple, which is pretty good. And we're starting to bottom out, and then we'll come up the other side. So let's see how this turns out for us. I'm going to speed this up. So let's look at a couple things. I've got a couple points at the bottom. That's pretty good. I've got a decent U shape. We're getting close. One problem we have is right here, this flat piece. This is backlash, and we need to address that. We'll talk about that in a second. The next thing we have to look at is our HFR. We get around 4, and we get up to about 14. So that is between 3 and 4 times. We could even go a little bit higher. To get those numbers to get a little bit further apart, we would need to increase our step size so that we're pushing our curves further to the left and right, which will get us a higher HFR on the edges. So let's do 2 things. Let's try to increase this a little bit to try to get a bigger number, a steeper curve, and let's also address the backlash. Now, from the backlash perspective, we are right around 136,000 here, and this is about 137,000, maybe a little bit more. So we're looking at about 1,000. So let's go ahead and make that modification. So if I go back to options, what I'm going to do here is I'm in overshoot. Now, backlash in or out, I'm going to go and change out. Never change both. One of these numbers needs to be 0. If you're changing in both directions, you're fighting against yourself. Now, I'm going to go ahead and say that the number we had when we were looking at it was at least 1,000. So I'm going to go ahead and try to do maybe 1,200. Let's see how that works. Also, to get a larger HFR, I'm going to increase my step size, and let's just increase it by another 50. So I've increased my step size, which should somewhat change my HFR, give me steeper edges, and I'm trying to address my backlash. So we can immediately come back and let's rerun autofocus. And I'm going to close these out. We don't need this information. And I'm going to go ahead and speed this part of the video up, and we'll come back when the curve is done. Okay, so you can see it's completed and it didn't complain this time. Now, I think I do want to adjust this a little bit. It looks like if I look up here from a fit perspective, it kind of slopes a little bit less initially and then slopes steeper. I think this may be a little bit more backlash we may need to address, so I may increase my overshoot a little bit more. And I can even try to drop the number of data points down to see if I can speed up my autofocus runs. But this looks pretty good, and if I come back to imaging and I go ahead and take an image right now, just a 5-second image, we'll see how it looks. And again, I've got a collimation problem, so don't worry about that so much. So this actually looks pretty good, pretty tolerable. I've got a lot of night glow right here, but that's okay. So the focusing, all things considered, looks pretty good. Now, I'm very quickly going to make one more modification and just to adjust my overshoot one more time and to lower the number of initial steps, because if I can get this to be a little bit more succinct, I'm going to be able to speed up my autofocus runs by doing less data points. So again, we'll let this run pretty quickly. Now this is a test, right? I'm just trying to fine tune it. If I don't like the outcome here, I will just go back to my previous results because I was very happy with what I just had. I'm simply looking to see if there's a possibility of me speeding up my autofocus runs throughout the evening by having less data points and addressing some of that additional potential backlash that I may have missed. Okay, so this still looks pretty good. Notice here the calculated position was 133,805. If I go back to my previous one, it was pretty close to that. Anywhere down in this flat part is going to give you good focus. You don't need to be dead in the middle. Being down in the flat portion at the bottom is going to give you appropriate focus. So if I go back again to the most recent one, I did it in less data points. I'm pretty close to where I want to be, but notice my HFR issue, right? So by chopping off data points on both the left and right side by shrinking the number of initial steps, I don't have all of that additional HFR I would have had. So to get that additional HFR, I can increase my step size or add the data points back in, right? Right now I'm at about 4. 3 times 4 is 12. I'd want to be a little bit higher. 4 times 4 is 16. So I could go a little bit steeper, or I could leave it like this. Again, play with it and see where you want to land. As a rule of thumb, 3 to 4 times the low number should be where your high is. And we want to have 1 to 2 points at the bottom here that we can use to get our good fit. So I may just leave it like this and see how it runs. You know, it's a very fast focus run at this point, so I'm pretty happy with it. Okay, one other thing I want to address with you, and this is new in 1.11, it's this hyperbolic R squared, and it depends on what line fitting you're using. I'm using hyperbolic. So what R squared is it says, as I'm looking at your data points, I'm drawing the hyperbola, right? I'm drawing that hyperbolic line, and I'm seeing how your data points match and fit to that curve that I expect. If I get a 1, that means I have a perfect fit, right? My data points match the hyperbolic line I expected. So a 1 is great. 0.8 or higher is really good, right? So what we have with this new feature is the ability to say in autofocus, if I come back in here, is I can say, what is my R squared threshold? So I can set this to a number. Let's say I set it to 0.9. Anytime during the night I have an autofocus run, I'm going to run my autofocus, and it's going to compare my data points to the hyperbola at that point, and it's going to give me this number, the line of best fit, R squared value, the threshold. If my autofocus run ends up 0.9 or higher, it's going to use that autofocus run as valid, and it's going to use that focus point. However, what if I have clouds or the seeing got poor momentarily? My R² value isn't going to be very high. I'm not going to meet the criteria for the line I expected to draw. So I'll actually have a number below 0.9 in that case. So what'll happen is it will disregard the current autofocus run and will fall back to the previously defined focus value. Now this can be really powerful. If you've ever had poor seeing or clouds roll through when autofocus occurs, you know that you can actually have a bad autofocus run, and then maybe for the next 45 minutes, you end up with subs that are all throwaway because they're out of focus. This allows you to avoid some of that. So just another reason to move to 1.11. Now, as far as this value, I think it comes out of the box as 0.7. I recommend probably moving to at least 0.8, get a feel for where your runs are falling over a couple nights, and then based on your seeing conditions, your bortle for your skies, and just your gear and focuser, you may find that you can move that up to 0.85 or 0.9 or even higher. But again, it's another reason to potentially move to 1.11. If you have any questions about that, definitely ask in the comments, but it's definitely something you should be looking at. For me here, I'm going to go ahead and bump it just to 0.85 for now, and we'll see how it goes. We're going to move on to my ZWO EAF focuser, and I'll be back in a second here, and we'll take you through that one pretty quick as well. Okay, here we are with Nina connected to my 61 EDPH2 with a ZWO EAF autofocuser. If I go look at my autofocus settings, it's pretty much default for initial offset, hyperbolic, which I would prefer. I'm going to do 2 attempts in case one fails. I'm not really going to change anything else. Notice my autofocus step size right now is 20. I'm doing 5-second exposures, and I have no backlash compensation configured. Let's see what a 5-second sub looks like. And again, the first thing you want to do is get near focus. So if you're not near focus, looping pictures, see how close you get. Actually, this looks pretty good. So I'm pretty close. Now, next thing I want to do is watch a star, and I'm going to change my focus. So let's see what 20 does. Let's go about 20. So I'm at 26,683 here. So let's just go ahead and take this to 26,700. It's not quite 20. And I'll move. I'm going to make sure it's moved. I'm going to take a picture, and I'm going to watch this star to see what it does. Again, I'm looking for 20 to, I say, 50% growth. I don't think we quite had it. So let's go and add maybe another 30. So we'll get up to, it's almost 50 at this point. Okay, I think I definitely had growth. If you look at this star size, and if I go back 50, which would take me about here, let me move it back near the original position, and let's see if we shrink by 20 to 50%. I think so. I think we had definitely a smaller star here. So I'm pretty happy with that. So let's go ahead and say that 50 is a good initial step size for us. So we'll come back to options, and I'm going to change this to 50. Now, I don't know anything about backlash or anything else. What are we going to do? We're going to just go ahead and, using this initial step size, let's just go do an autofocus run. Okay, we're back. So a couple things to note. My HFR says it's 182. From the graph, I'm around 2. 4 times multiple would be 8. So I think my step size is pretty good. I'm getting up around 10 and 8 on one side. If I look over here, it does look like I have a little bit of backlash. So this backlash is going from, what's that, 26.8, 26.850. So this is about 26.825 to 26.875. So I got about at least 50 of backlash. There could be some more hiding there, but I'm going to say there's at least 50. I'm going to go ahead and say, let's just call it at 75. We'll do an overshoot of 75. So I'm going to go ahead and try to get rid of this backlash with overshoot, and I'm going to cut down the number of initial steps. So let's go do that real fast. Cut this down from 4 to 3. I'm going to leave that at 50 for now, and I'm going to change my overshoot. Remember, only one of the numbers, and I'm going to set this to 75. I'll immediately come back. I'm going to start another autofocus. All right, well, I don't think you can beat a curve like this one, right? So this looks great. My fit is 1, which is perfect. If you look at this data, My low is around 2, my high is above 6, so that's a 3-time multiple. I'm happy with that, between 3 and 4. I cut down the number of steps, so my autofocus runs will be quicker. I've got nice steep sides. As you can see, the real trick here is starting near focus, determining a good working value for your initial step size, and then after you run with a single autofocus run, determine if you need to increase your step size because you don't have enough range between your low and high values of your HFR, and determine if you need to address backlash. And then it's just fine tuning. Okay, here's the last autofocus setup run through, this time with my Astromechanics Ascom Canon EF lens focuser. The first step is to get us at or near focus before we begin. I'll move the focuser a couple of times to get us there while looping 5-second exposures. While I'm doing this, I'm looking at the stars to see how much they change as I move 5 steps at a time. Okay, this looks pretty good. Let's run an autofocus cycle. This isn't too bad. Shape is okay, couple points at the bottom. HFR goes from about 3 up to about 20, which is more than enough. The issue on the right could be backlash, but I know it's something else. With this Canon lens, the focal point for stars is very close to the maximum manual focus movement that's allowed on the lens. This means that if I continue to increase steps in that direction, I'm going to hit a physical limit on the focuser and never get a higher HFR. Let's jump into the configuration. This happens to be Nina 1.10 since I use this for synchronized dithering, which isn't supported in 1.11 yet. It doesn't matter for autofocus though, the autofocus configuration is the same. First, I'm going to increase the exposure time to get more stars. When I was finding focus, I was only moving 5 steps at a time, which seemed to give me the 20 to 50% star size increase I needed. Here, during the autofocus run though, I had it set to 10 steps. Since our final top and bottom HFR multiplier was closer to 7 times, we can lower this from 10 steps, and let's just split it in the middle and go with 8. Let's try another run with these changes. Wow, that looks great, but we're getting an error at the bottom right that says our calculated versus actual HFR is off by more than 25%. Here's the thing, because this focuser uses very few steps for movement, it produces a tight curve. We can address this though by changing the curve fitting model in our configuration. Let's change this one from hyperbolic to parabolic. You could even try to add in trend lines if it's needed. Also, while we're here, let's drop the step size to 6 and initial steps to 3 so that we can lower the top to bottom HFR multiple and speed up our autofocus runs. And we'll run it one more time. There we go. Good shape, no complaints, proper multiples. We should be done. Great stars. Yep, I'm happy with it. I hope you feel like you learned something today and you can now fine-tune or correct your own Nina autofocus configuration. Let me know if you have any questions in the comments. And as always, clear and focused skies.